Hello, thank you for watching this video. So on this video I'll be doing question 2 of November 2022 question paper physical sciences paper 1. So this topic is Newton's laws or forces. I don't know the name of this topic. So yeah, let's try to do it. So I'll read question 2 and then answer the questions that follow. So question 2. Crate P of mass 1.25 kg is connected to another crate Q of mass 2 kg by a light inextensible string. The two crates are placed on a rough horizontal surface. A constant force of 7.5 newtons acting at an angle theta to the horizontal is applied on crate Q as shown in the diagram below. The crates accelerate at 0.1 meters per second to the right. So what they're saying is crate P experiences a constant frictional force of 1.8 newtons and crate Q experiences a constant frictional force of 2.2 newtons. So I'll just try to explain this. So we have this crate P of 1.25 kg and this crate Q of 2 kg. They are connected by this light and extensible string and are placed on a horizontal surface. So a force of 7.5 newtons is applied on box Q at this angle theta to the horizontal. So this box of yours P experiences a frictional force of 1.8 newtons and this box Q experiences a frictional force of 2.2 newtons. So we are told that these two boxes accelerate at 0.1 meters per second to the right. So they are accelerating at 0.1 meters per second to the right. This is what they are telling you. So let's go to the first question, 2.1. So state Newton's second law of motion in words. So they want you to state Newton's second law of motion in words. What does Newton's second law of motion tell you? That's what they are asking you. So the Newton's second law of motion tells you that if you have a net force acting on an object, right, that object will accelerate in the direction of the force, and the magnitude of the acceleration, that is of the acceleration caused by the net force, is directly proportional to the magnitude of the net force and inversely proportional to the mass of the object. So that's what Newton tells you. So the net force acting on an object will cause an object to accelerate with a magnitude that is directly proportional to the force and inversely proportional to the mass of that object. That is Newton 2. I'm not sure if I need to write that down because it is simple as that. So I'll just repeat for I'm not going to write it down because it's straightforward, because it just tells you that the net force causes acceleration, right? Force acting on an object will cause an acceleration, and that acceleration will have its size, the size of that acceleration will be directly proportional to your net force and inversely proportional to the mass. So I'm not going to write that, but that's what Newton 2 tells you. So let's go to another question, 2.2. Actually, you can just say 2.2 here. So draw a labeled free body diagram for crate P. So they want you to draw a labeled free body diagram for this crate P. So when you're doing trying to answer these questions that involves Newton laws, it's very important to have a free body diagram. You must understand the free body diagram of each and every object or every box that you are dealing with. Once you know that, then you will be fine, I think. But if you don't know you can't draw the free body diagrams, then you are in trouble. So let's go. So they want us to draw the free body diagram of forces here. So you need to be able to identify what forces are acting on this object. So free body diagram, you draw your dots there. So fine, you have it. What forces do you know? You know that there's a frictional force on P. You were told that. So the frictional force is in this direction, opposite direction of our motion. So this is the frictional force, right? What other force do you have? The force of the strain on this, caused by this strain here on P. So this is the tension force on the strain, that one. So it's the tension. What else? So this diagram of yours is on the surface. So there's a force of the surface on the object. The force of the surface on the object, which is the normal force. What else do we have? The weight of this box. You can always start with the weight. So the weight is directly downwards, like this, which is force of gravity, or you can just say weight. So these are the forces that are acting on this box here. So this is the box P. This is P, or you can say it's the 2 kg box. These are the forces that are acting on P. You have them, they're like this. So now, let's say now what I'm going to do is not on this question paper, but it's important to understand it as well if you are dealing with such questions. So now, let's suppose that we want a free body diagram for Q. So you need to, so now this is more like an exercise. I'm teaching you how to identify forces, because they are very important. If you must know the forces that are acting on your objects when you're dealing with such things. So, if you want the forces, let's draw the free body diagram of all forces acting on Q. So I'll have my Q here. This is not asked, but it's more like an exercise for you. So if you look at P, you know P as well, have frictional force. So you will have your frictional force there. So let's say frictional force of P on P. And then this is the frictional force of Q. This one. What else do we have? You have the applied force. So this is the applied force. Force applied. So, and it's applied at this angle theta here with the horizontal. So these are complete questions. So this one I'm just making it up as an exercise to show you how to draw a free body diagram for the second diagram. Applied force. What else do we need? It's the weight, it's the force of the surface on the box, which is the normal force. Here's the normal force. What else? And then it's the weight. Or force of gravity. Are we done? No, we're not done, because also there is tension on this box. So also the tension is in this direction, because this is T here. So now is the force of this is the force on Q that is experienced from the strain. So it's pulling Q in that direction. So it's equal to this one, this tension and that tension, the same tension, but they're just in different direction. On P is pulling P forward to the right. On Q is pulling Q backward to the left. So this is the free body diagram for what? For Q, and that is free body diagram for P. So say this is free body diagram for Q, or the 2 kg block. 2 kg block, and then this is the 1.5 kg. Made a mistake here, 1.5 kg block. So, okay. So someone else, this free body diagram is correct, right? But it's not very useful or easily showing you things that you need to consider if you are performing calculations. That's the downside of this free body diagram. So if you want to perform calculations, it won't be easy for you to just pull them out of this. So some other people, they like drawing it like this. we'll say, okay, you have normal force, we have your frictional force, we have your tension, we have your weight or force of gravity. Then this is where things become different. So the force applied, because force applied is at an angle, they break down the force applied into two components, the horizontal component and the vertical component. That's what other people do. They break down the force applied into two components, the horizontal component and the vertical component. So the horizontal component will be like this. So this is force applied, right? But in the x direction, which is in the horizontal direction. And then you also have what? That one then. The force applied in the vertical direction, which is in the y direction. That's how other people look at it. And now, if you are dealing with a situation similar to this, you will know that your force applied in the x direction is called FA, force applied, times cos theta, where your theta is the angle that your force vector was making with the horizontal. And then your FA applied in the y direction, the component, it will be your FA sine theta, where theta is the angle that the original force vector or the resultant force vector was making with the horizontal. So this is what you do. So now, if you are, okay, let me just stop here and continue with the question. 2.3. So the lower part, this one, was just for all the lower part here, just for your own educational purposes. It is not asked, but it's something that I think is important that you know, because if in order to perform calculations of this thing, you need to know these things. If you don't, then you will be in trouble. Okay. 2.3. Calculate the magnitude of the tension of the string. So they want us to calculate the magnitude of the tension of what? Of the string here. So they want the magnitude, tension of the string. So how can you do this? You can say, okay, you can say, you can use Newton 2. The reason they were asking you to state the Newton 2 second law of motion, they were not because they were bored or they were just trying to give you full marks. Whatever, many things that you state here, you are going to use them, you are going to apply them. So they want you to state it and then apply that law, apply that theorem. So when they ask you to state Newton's law of motion, you somewhere down the line you'll have to use it, because this is Newton's law, second law of motion. So now, what we're saying there, we're saying the net force acting on an object will cause, on Newton 2's second law of motion, the net force acting on an object will cause an object to accelerate with a magnitude that is directly proportional to the force and inversely proportional to the mass of that object. What we're saying is this F net is equal to ma. This is what Newton 2 is. You're saying the net force acting on an object will cause an acceleration. And the magnitude of the acceleration is directly proportional to the force and inversely proportional to the mass of an object. That's Newton 2. So now, when you want to find the tension, that means you have to use Newton 2. So you say F net is equal to ma. So what is F net? F net is your sum of your forces acting on an object. That's what F net is the resultant force, the sum of all forces acting on an object. But if we're talking about this one here, right, this force, how many forces are acting here? 1, 2, 3, 4. There are 4 forces acting on the box P or crate P. So on these 3 boxes that you are dealing with, there is no need of adding these 2. So you can add them on the net force, but it's fine, let's do that. But let's say, okay, let's say going up is positive and going to the side is negative. Is positive as well. So if you have the force going up, it's positive. If you have a force going to the right, it's positive. So now, if we add our forces, we'll say, okay, F normal force is going up, so it's positive. Fn plus another force, which is tension, is also positive because it's going to the right. Then plus this force here is going down. Our weight will be negative because it's going down according to our coordinate system. So this will be negative force of gravity plus frictional force. So we said forces going to the right are positive, the one going to the left will be negative. So plus negative force of friction on Q is equal to MA. This is what this is. So now, there is no motion in the vertical direction. There is no motion in the vertical direction. So what that means is, this force here, the weight, and the normal force are equal to each other. Which means now, your weight and your normal are equal to each other. So what I always say is, when you are dealing with these, with Newton 2, I always advise that you focus on the forces in which there is motion. The vertical ones, or the ones in which there is no motion on, most of the time they are balanced. So now, if you are dealing with horizontal objects moving horizontally, then the vertical forces will balance out because they don't have motion in the vertical direction. If they are up the incline, the only force that you should be interested in are the ones that are parallel to the incline. The ones that are perpendicular to the incline, nothing, because they are balanced, there's no motion there. If it's vertical like this, objects can move vertical like this. So the forces that you should be interested in are the vertical forces, right? The ones that are perpendicular to your displacement, they do not make any difference because they are balanced out, they are in equilibrium. So what you have now, you have your T minus force of friction on Q, not Q, it's P. So this is the box that you're working with, on P, which is called MA. This is what you have, 2.3.1. So what do you do when you're here? So you see now, you're only left with T and force of frictional force on P. So you're only left with the horizontal forces because that's where your motion is. You have displacement in this direction, not in the vertical direction, which means these forces are balanced out. So what do you have? You want the tension. So T minus frictional force. You have the frictional force on P. The frictional force on P was 1.8 newtons. 1.8, which is equal to M. What is the mass of P? It's 1.25 times A, which is the acceleration, 0.1 meters per second. So you solve for T here. So T is equal to 1.8 plus 1.25 times 0.1. Punch this in your calculator. Let me find mine. So I found mine, so I'm going to punch this. So it's 1.8 plus 1.25 times 0.1. So T is equal to 1.93 newtons. This is your tension. You have it. This is how you do this one. Then we go to the next question. So 2.3.2, calculate the angle theta. So they want you to find the angle theta, this angle here. Calculate the magnitude of this angle here. So this angle, this theta is on this 2 kg box. Is the force that, the theta is the angle between the force applied on the 2 kg box and the horizontal. So now, this was not asked, but now it is important. So we know that T is 1.93 newtons, right? So now, to calculate the value of that theta here, you use the same principle. I'm going to clean the board and then we apply that principle. So it's 2.3.2. So now, to find this angle theta there, you use the same principle that you use here. You say, I'm going to use Newton 2. So Newton 2 says F net is equal to MA. But F net of what? Of the box of interest now, that the angle is forming on. So now, you must sum the forces here. What are the forces? So if you look, then now you see you need to, in order for you to be able to sum the forces of this box, you need a free body diagram of that box. No one asked you to do that. You must know that in order to answer these questions, free body diagrams are very important. If you don't have free body diagrams, or you don't understand them, or you don't know the forces acting there, then you might be in trouble. So, what you do is say, okay, we look at our box. What are the forces acting on this box here? It's frictional force, it's tension, it's Newton, it's normal force, and the weight or the force of gravity. But like I said here, because our box is moving in this orientation in the horizontal direction, these forces, these two, or not that these two, the vertical forces will balance out, not just these two. Let me clean this. So the forces that you are interested in are the vertical forces. But then, the problem with this one is at an angle. So now, you need to resolve this force that is at an angle into its components, the horizontal component and the vertical component. So, you need to find the horizontal component of this, which is this one, and the vertical component of that, which is that one. And you know how to calculate them. So, if I want the net force, I can do it the boring way and write all of these forces. If I want the net force here, this paper diagram is the same as this one, except here, I'll split the components. Here is this component, the horizontal component is that one there. So the resultant, I didn't draw it. I only draw the components here. So this one, this paper diagram that has the components, I think is the most valuable one, especially if you need to do calculations. Because it's easy to identify the forces that are important. So now, these three, this one, and that one, they all balance out. So when you add these two forces, they're equal to the weight. That's why you don't have a vertical motion. That's why we're at equilibrium in the vertical direction. The forces are at equilibrium, they're balanced out. So these two, if you add Fm plus Fy, they are equal to what? To Fg, or the weight. So these three guys, they balance out. And then now we are left with the horizontal guys. So, but these are not our are not the forces that we're interested in the moment. The ones that we're interested in are the ones in which the motion is in, the horizontal ones. So the boxes are moving from left to right. So we're only going to consider the forces that are horizontal. So what we're going to do, we're going to say, okay, positive up, positive to the side. Again, what do we do? So we want to add our forces. We want to find the net force, right? We want to find the net force. Net force is the sum of forces acting on an object. So our forces now that we are interested in, we're going to focus mainly on the horizontal ones because the ones that are vertical are going to cancel out. So we're going to say Fax plus frictional force of Q, which is negative, because it's going to that direction, plus the tension, which is also negative because it's going to that direction, is equal to MA. Right? So what do we have? We have FAX minus frictional force on Q minus tension is equal to MA. This is what you have. And I did say that FA in the x direction is equal to this thing. It's called FA cos theta. So FA, this is called FA cos theta minus frictional force on Q minus tension is equal to MA here. So then from here you substitute. What was the force applied? 7.5 cos theta minus frictional force, which was 2.2 on this box, minus 1.93. This is called M. What is the M? Is the 2 kg times 0.0 or 0.1 meters per second. So then you solve your cos something, your cos theta here. So you transpose this 2 to that side, you have 7.5 cos theta is equal to 0.2 plus 1.93 plus 2.2, then you divide by 7.5. Divided by 7.5. So cos theta is equal to whatever the answer is. The partition of calculator says 0.2 plus 1.93 plus 2.2, all divided by 7.5. So this is 0.58. Then your theta is equal to arc cos 0.58, which is equal to what? 54.74 degrees. So that's what the angle is. That is the angle of theta. And you're done with this question. Then we can go to question 3, which is the projectile motion. Easy.